Hello friends, myself Shriram Korade. So let's now understand one more application with respect to 2D array, and that is matrix multiplication. So let us say that we have two matrices here which are given here. So matrix 1 is 4 by 3 and here it is initialized with some data. Similarly there is a matrix M2 which is again initialized with some data. Now if I want to basically do matrix multiplication, then I need to have some basic understanding. So to do that basic understanding, let me just take you to slides and then I will show you this. So here if you say that you have matrix A and matrix B, then if matrix A is of the size m by n and B is of the n by p, then essentially m by p will be the final dimension of the resultant matrix. That means the important point here to notice rows into columns and columns into row. So this particular thing, rows into column, this is column, and then this is again rows into column. Okay, so this column and this rows should be equal, then only you can basically carry out matrix multiplication. So that's the prerequisite, and we have seen that prerequisite even during our college days. Now if I want to basically multiply, let's say, a matrix of 3 rows and 2 columns with 2 rows and 2 columns, okay, because here the main thing is 3 rows and 2 columns, and here basically 2 rows and 2 column. Okay, so that means now you will carry out this multiplication, like a11 will get multiplied with b11, then a12 will get multiplied with b21. So this will basically give me the a00, that means the very first element. That's what I'm trying to tell you. Similarly, if you want to have the next element on the same row, then what you will do is this a11 multiplied by b12, that means this column you are going to take, and then a12 multiplied by b22. So this will basically give the second element. Similarly, you can have the this is 0th row, this can be the first row, and then basically you can have, so this is the 0th row, this is the first row, and then this is the second row. So essentially you can just compute using this equation, which is very simple now. So essentially what you do, this row will get multiplied with the column. Similarly this row will get multiplied with this column, so to have this element. Okay, so to have this element, you will have this column, and the row will be multiplied to this column. Similarly to have this element, then this particular row will be multiplied by this 0th column. So this is the row 0, this is the column 0 of this, okay, and this is column 1. So like that if you do, then you are basically able to do the matrix multiplication. So let's take an example now which I have shown you here. So here if you look at it, there is 1 2 3, and this is like 2 rows and 3 column matrix, and this is 3 rows and 2 column matrix. Okay, so here you can very clearly see 1 into 10 plus 2 into 20 plus 3 into 30. So this will give us the first element, very first element. Similarly, that the same row and then the first column here. So this you do, that is 1 into 11 plus 2 into 21 plus 3 into 31 will give you this element. So like that you basically will get this. So here you are going to take first row, because this is first row, this is 0th row. So first row will be multiplied with the 0th column, and then first row will be multiplied with the first column. So like that if you do, then you are going to get the final answer, which is 2 by 2. Why? Because it's 2 by 3 and then 3 by 2. So final, as I told you, the dimension is m by p. Okay, so that is what was highlighted here. So if we have understood this, now we need to translate it into the code. Now the important thing here, when we are going to do, obviously we will have I and we will have j. So I and j we anyway will use as part of the loop. The important thing here to notice, we need to have one more variable, say we can call it as k or l, whatever. Let's say we call it as k. Then this k will be a third variable which will help us to do this sum. This is very important, this sum which I told you, or which is marked here in yellow like this. So that, why? Because now you are going to multiply row multiplied by column, and then to that you are going to do summation. That means now here you will see, though there are 2 rows and 2 columns finally, but the summation, that means the multiplication and the sum, essentially was 3. Why? Because 2 by 3 and then 3 by 2. So that means k here will be 3, and then obviously I is 2 and j is 2. Why? Because that is the way you basically do. Like you have the two loops ij, so no issues. The main thing is internally how are you going to do the multiplication. So this we need to translate it with the example that, or the data that we have already taken in the code. So let's continue with this now. So let's go to the code. And now what now remains is we require a third variable, as I have told you, and then obviously we have to compute a sum. So to compute the sum, we will use a temporary variable called as sum. Okay. Now we will write loops. Okay. So let me just copy this code where we are going to do multiply. Okay. Because the below code is the same old code which we are using it for showing the resultant matrix which we have done during addition. Okay. So here now you will get result matrix which is a 4 by 4 matrix. Essentially it is m1 multiplied by m2. Why? Because now you can see this is 4 rows 3 column and this is 3 rows 4 column. That means our resultant matrix, that means m3, will be 4 by 4. Okay, so that is what I have mentioned to you on the slide. Now we want to multiply. So as I have told you, we will have the loop. Like here you basically will have I is equal to 0 and then I less than 4. Why? Because there are 4 rows, and then so we have done, and here you will see the output, that is j. So again here this is the 4. Okay, because our resultant matrix will be 4 by 4 cross 4. Okay, now let's get rid of all this. Now what we basically need to do is very important thing, and that important thing is what we need to know. Now we need to compute the sum, and the sum needs to be computed for each entry of that particular matrix. So what we should be doing is, like, we should initialize this sum to 0. Why? Because now you need to multiply that which I have shown you on the slide. So here now you will have a variable k, and k will initialize with, that means it will start with 0, and now here you will see there are 3 columns here and there are 3 rows. That's what I told you. So that means k will be 3. Okay, so this is what this particular row will get multiplied with this column. This is 0th column. Okay, so it's 3. So that's why here you will have a loop which will have k is equal to 0 to k less than 3. That means 0, 1, 2, 3 entries, and then k plus plus. Okay, so k plus plus is what we will do. Okay, now we need to basically do the sum. So how do you do? So essentially 1 multiplied by 13 plus 2 multiplied by 17 plus 3 multiplied by 21. That is what we need to compute when say I is equal to 0, j is equal to 0 and k is equal to 0. That means k is equal to 0 to 3. That is what will happen. That means we will have s is equal to s plus what? So s plus matrix 1 m1 of I, because we will use I, and then here that is what I told you, we are going to use k. Why? Because this is the first row, I is equal to 0 and then k will be used instead of j. Normally we are habituated to using j for a column, but here we are using k. Why? Because this is what should match, or this is what will match to here 3 columns and here there are 3 rows. So that's what will happen. So we are going to take m1k, so k will basically will go from 0 to 0 to 0, 1, 2, that means 3. So here m1 multiplied by m2. So m2 will be now k once again here. Okay, so k of j. If we understood this, we are done. Okay, so finally we got the answer, that means here s. Now this is the inner loop which is there for doing that matrix row wise, row to column, row multiplied by, just let me put this, so row multiplied by column, this is what will happen. So that, and then finally I will have to populate matrix 3. So matrix 3 is ij. So let me just populate this matrix 3 with whatever the sum value that we have computed. Okay, so let's see this in action now. So here, and then obviously we are printing here the matrix 3. Okay, so instead of addition I am using the same code which I used in the earlier video. Okay, so we are done now. So let's understand it now. So what will happen? I is equal to 0. So that means 0th row, j will be 0. Okay, so we are taking the 0th column. Okay, and now here you will see this the k. So k we have started and k we initialize to 0, and that is where the important thing will happen now. So that means we want to go across column and here across row. So that's why I will be the outer loop. This is the outermost loop. This is the outer loop, outermost. Let me put it. That means then this is obviously this is inner, and then here this is what I mentioned matrix, that is that row into column you do. Okay, so here this k is controlling that. Okay, so k will now here the we are using this, so k will be what, it will give me 1 2 3, that is what I will be 0, so k will be 0 1 2. Okay, so that is what essentially the values are 1 2 3, and then m2 essentially j, so j will be 0, and now basically what we want is sorry, j is 0, and then here what we want is 0th column, that's why here j is used in column. Okay, and k is now controlling the row, and k will be now 0 1 and 2, that means you will get 13 17 and 21. So let's, like that you will have 4 5 6, then like that you will have 7 8 9, and like that you will have 10 11 12, and obviously 1 2 3 will be also multiplied with the first 0th column, then first column, second column, third column, like that. Okay, so that's the way in which I mentioned to you on the slide, the same thing will actually happen. So let's now run this code, and let's see the output. Okay, so output is 110 116 122. Now the question is it correct? Obviously, if it is correct, how will you verify? So you can always use a calculator and do this paper pen calculation. Otherwise, there are other smarter way to do that. So let me just make it little small here. If we just adjust it little bit so that we can, yeah. So this is okay, I believe. Right, so this is okay, and now we can go to this one. Here you can see there is a calculator.net which is available directly on the net. I have already fed these values 1 2 3 4 5 6 7 8 9 10 11 12 and then 13. This is 4 by 3 column, sorry, 4 by 3 matrix, and this is 3 by 4, and then if I just press AB, I already pressed and wanted to check. So this is what basically you will get this 110. Okay, so you can see this. Suppose if I change this here, say to 4 and do AB, then you see it changes. So let me just now once again make it 3, and now you can see this. So this is, let me now bring this and keep it side by side. So these are correct: 110, 116, 122, 128, 263, and then 602. Okay, it got printed twice. Okay, so here now you see there is 416, there is some mistake that has happened. Okay, so now we need to rectify that mistake. So what can be the mistake here? Let's see this. K is equal to 0 m1, and then j is equal to 0, j is equal to 4, and then k plus plus, and let me just, yeah, so here it was wrongly put. I hope now it will be, it should work. Yeah, so now it is working correctly. So let's do it small, little this one. Okay, so now we can, so now it is correct. So 110, 116, 122, 263, 416, 440, 569, 602 and 635. So what did I, when I pressed this, it was basically, it was not done correctly. Okay, so it should be part of this. Okay, and that is what I ensured, and I believe maybe because of scrolling, it didn't scroll properly. That is what I can think of. Okay, so that's the way essentially you can see this. So finally we wrote S, and you can get this answer. So I hope you like this video, and you can always check this on calculator.net, the answer that you are getting. Thank you.